you'll create your first collections of data. Like last time, you'll touch on a number of different concepts. Like before, instead of defining terms up front, we'll define these terms as we use them. Here's what we'll be learning. Don't worry, just like before, these terms should all look foreign to you. At a high level, we'll discuss how to hold data in these next two lessons. Start by navigating to repl.it/languages/python3. You'll then be greeted with a screen like this one. We start with a collection called a list. A list is what the name implies, a list of items. How do I define a list? We can make this concrete by looking at some code. We always use square brackets, one to start the list and one to end the list. We also always use commas to separate each item in the list. In this case, our items are numbers. You can also have lists of strings. Recall a string is a piece of text, denoted by double quotes or single quotes. Let's see this in action. This is a list of numbers. This is a list of strings. There are three possible mistakes or errors. One possibility is a syntax error, end of line while scanning string literal. This means that the double quote I highlighted here is actually the beginning of the final string that never ends. This just means in practice that we forgot a double quote before Alex. So if you receive a syntax error, double check your double quotes. The second possibility is an ellipses like this one. This simply means that you didn't add the square bracket for the end of the list. If you see these ellipses, go ahead and type in the end square bracket and hit enter. The third possibility is a fused set of two names. In this case, John and Alex have been mashed together because we forgot a comma between those two strings. So if you see names fused together, go ahead and double check your commas. Now let's assign a variable to this list. Here's a variable, names, assigned to the list that we just defined. To make sure we define this variable correctly, type in names. Hitting enter returns the list of names. However, what if we only want the first name? How do we get an item from a list? Let's look at the list of names we have. We want the first one, the first name. Step number one is to know which position this item is in. This item is in the first position. Step number two, find the index for the item you want. In most coding languages, the first item is actually at index 0. The second item is at index 1. The third item is at index 2, and so on and so forth. In step number 3, use square brackets and the index to get the item. This code will return the first name in the list, which is Jane. Let's try this now. Let's go ahead and type in names, square bracket of 0. Hit enter, and now we see Jane. We can also access the other names in this list. Now, what happens if we access names of 1000? No such item exists, so we'll get an index error. An index error means that the index we provided is invalid. The list only has 3 items in it. Nothing exists at index 1000, so Python raises an index error. Just like we can assign variables, you can also set items in a list to a value. For example, we can change the first item in the list to Jen. Go ahead and type in names of 0 is equal to Jen. That looks like a lot to unpack, so let's work through it from left to right. Here, names of 0 refers to the first item in the list. The equals operator assigns the first item to the list to the value. Our value is a string with Jen. To check that our assignment was successful, type in names and hit enter. This gives us the modified list of names. You can also check which names are in the list by using the in operator. For example, to check if Jen is in the list, go ahead and type in Jen in names. Notice that when we updated the list, we spelled Jen with an uppercase J. This means that when we check for containment using in, we have to use Jen with an uppercase J as well. The strings must be identical. And that gives us true as expected. We can also check other names. Let's check if Jack is in the list. Jack is in fact not in the list, so as expected, we get false. Now, let's move on to our second data collection, a dictionary. What is a dictionary? A dictionary maps keys to values. Think of it like your dictionary at home, which maps words to definitions. Let's make this more concrete by seeing some code. How do I define a dictionary? We always use curly braces, one to start the dictionary and one to end the dictionary. We use a colon to separate the key from the value. Here, the key is a string, denoted using purple. Here, the value is a number, denoted using pink. The dictionary maps the key Jane to the value 3. We use commas to separate entries in the dictionary. Let's try this in code now. Go ahead and type in Jane, 3, and John, 2. This is the dictionary mapping from names to numbers. In the top right, I'm going to go ahead and click on Clear. Again, you don't have to do this. This is just so that code isn't clustered at the bottom of your screen. If you also decide to clear your screen by clicking on the button in the top right, you'll have to hit Enter after hitting Clear so that you can see the orange caret interpreter once more, waiting for your input. Now let's assign a variable to our dictionary. Let's say that this dictionary maps names to numbers of cookies. So we'll go ahead and call the variable name to cookies. Notice here that names to cookies is a variable name, which means we're restricted to only letters and underscores, like we talked about in a previous lesson. These are underscores here, not dashes. Let's go ahead and now define name to cookies is equal to the dictionary that we just typed in earlier. So Jane has 3 cookies and John has 2. To make sure that we define this variable correctly, type in name to cookies. Hitting Enter returns the dictionary, mapping names to number of cookies. However, what if you only want Jane's number of cookies? How do I get an item from a dictionary? All we need is the key we're interested in. In this case, we want Jane's number of cookies, so we need the key Jane. Use square brackets and the key to get that item. This code will return the number that Jane corresponds to, which is 3. Let's try this in code now. Go ahead and type in name to cookies and pass in the key Jane. Notice that we spelled Jane identically both times. The first time was all lowercase and so is the second time. These keys, these strings, must match exactly when you're typing them both times. We can also do the same thing with John. Now what happens if I try looking up the number of cookies for Bob? Note that Bob is not in our dictionary. So here, we would instead get a key error. A key error means that the key does not exist in the dictionary. If you see a key error, you have a typo in your key. Just like you can modify lists, you can also modify dictionaries. Let's go ahead and type in name to cookies of Jane is equal to 10. Here, for the key Jane, we change the value from 3 to 10. To check that our assignment was successful, go ahead and type in name to cookies. Hitting Enter returns the modified dictionary of cookie counts. You've learned a lot in this lesson. This is a quick summary of the concepts you've touched on: lists and dictionaries, how to both get and set elements, and finally, how to check containment. If you'd like to access and download these slides, visit this URL. You can now represent any data of your choosing with Python data collections. However, how can we modify these collections of data in more complex ways? Maybe we'd like to reformat some text or perform some computation. In the next lesson, we'll discuss a coding concept called functions.